Good morning, everybody. Happy Wednesday. Our first video today is going to be me talking a little bit about our homework assignment. So again, I'm not asking you to actually submit the homework, but I am expecting that at home you are completing it. So the front page of the homework had a bunch of equations of functions in the top row, and then a bunch of graphs down below. And you had to match up the correct equation to the right graph. So looking at this, it can be a little bit overwhelming at first. So I just want to go through some ways to make this a little bit easier. So the first thing that I did was up above, I identified all of the exponential graphs. So this homework dealt with exponential graphs and quadratic graphs. And we talked about that a little bit in the video yesterday and the difference between them. So in an exponential function, you are going to have a number base and the exponent is going to be the variable x. So there are 4 exponential functions that I wrote exp on top of, and I just highlighted. So the ones down below, the graphs down below that are exponential are going to look like a curve, but not a U. So 2, 5, 6, and 9 are the exponential graphs. So remember we talked about in the video yesterday, if the graph as you move along the x-axis goes farther and farther away from the x-axis, the base has to be greater than 1. For this curve to be above the x-axis, there has to be no negative out in front. For number 5, the function as we move along the x-axis gets closer and closer and closer to the x-axis. That means that we need to have a base that is between 0 and 1, a fraction. For number 6, we again, as we move along the x-axis, the function gets closer to the x-axis, but it's below the x-axis. And what makes it below the x-axis is the negative out in front. And again, what makes it get closer and closer to the x-axis is the fractional base. And then for number 9, we have the function moving farther away from the x-axis, and that's from a base greater than 1. What makes the entire function below the x-axis is the negative out in front. So hopefully that clarifies how I came up with the correct matchings for the graph and the exponential functions. Now, the remaining functions up here are quadratics, and then the remaining graphs down here with the U's are parabolas which match with the quadratic functions. I do want to note one error or typo on the homework, and I do apologize for that. For this second quadratic, there should be a negative in front of this 7/4. And the error in the graph that matches to that is number 7. So I'm going to talk a little bit now about how I matched up the parabolas and the quadratic functions. So the first thing I took a look at was the graphs, and I noticed that like this graph seemed to be a little wide. This one was kind of in the middle, like medium width. And then I had some that were a little bit thinner. So I wrote myself a note here, like this one to me looked wide. This one to me looked thin. So I looked up above at some of the quadratic functions that I was taking a look at. And in order for us to get a thin parabola above the x-axis, it means that I cannot have a negative out in front, which I don't here, and the number in front has to be greater than 1. Now, because there was a typo here, you might have also selected this, this function for this graph. That would have also been okay based on the typo. But again, this number out in front being greater than 1, 7/4 is also greater than 1, makes this graph thin. So I selected y equals 3x squared as the equation for this one. This one then looked a little bit wider to me. So again, I need a positive. There has to be no negative out in front for this u to be above the x-axis. But it looked wider. So I knew that in order to make this u wider, in front there had to be a number less than 1, between 1 and 0, a fraction. So I scanned over the possible graphs, and I saw that there's a positive 1/3. That would make the graph wider. This one had like a medium width. I saw like it wasn't as wide as this one, but it wasn't as skinny as this one. But I noticed that it was below the x-axis, which is why I selected y equals negative x squared. Moving to the bottom row, again, I kind of left this one for last, but I noticed that these two look to be about the same width, but this graph was completely above the x-axis. So I chose the same function, just with a positive in front. And that one was the first one. And then the last exponential was down here, and it looked wider than these two, which were a medium width, and it was upside down. So I needed a negative in front, and I needed a number between 0 and 1, which is why I selected negative 1/2 x squared. That left me with this one, which I knew couldn't be the equation as printed, because as printed there's a positive. So if this were positive, it would be going up. So again, I do apologize for that error here, but what I really wanted us to understand from the lesson yesterday and doing some of these homework problems is I want us to start to see and notice the difference between exponential graphs and parabolas, quadratics. And I want us to start to understand what some of these features do to the graph. Like a base that is greater than 1, a base that is less than 1. Like how does that affect what we're looking at in the graph is what my goal was in yesterday's notes, and then with us completing the homework, doing some extra practice with that. If we flip over to the back, I am going to post a PDF of this key so you can take your time to look at my work and your work to see if you made any errors or you have any questions. There are just a couple things I want to talk about because it's been a little while since I've seen you guys and a little bit since we've been doing exponent properties. So just a couple things quick here to review. Remember when we have a negative exponent, like we do in number 1, the exponent here is -2. To make the exponent positive, I flipped the entire fraction inside parentheses. When we are multiplying like bases, we're multiplying x to the 4th by x cubed. I want to simplify that to a single base, and I add the exponents. 4 plus 3 is 7. When we have like bases that we're dividing, so we're dividing x to the 4th by x cubed, we want to write it as a single base, but we want to subtract the exponent. So 4 minus 3 gives us 1. So again, I subtracted the exponents here, multiplied the bases, so I added the exponents, and then we had a couple where we had to apply a power of a power. So that's kind of some of these down here in this last column. So what I decided to do first for example number 16, like I have exponents inside the parentheses, I have an exponent outside the parentheses, so power of a power. I first decided to simplify in the parentheses. I noticed 2 and 4 simplify the coefficients. I noticed I had a like base of a and a, which I also simplified to a squared. The next thing I dealt with was the negative exponent, which I made positive, and I made it positive by flipping the fraction that I had inside the parentheses. Then I squared the numerator and squared the denominator. And remember, when you have a power to a power, that is when you have to multiply the exponents. So I did that as well down here. I first simplified in parentheses. I simplified the 2 bases of D, I simplified the 2 bases of E, and then I applied the power of the power. So I cubed 3, I cubed 4, I cubed D to the 9th, so 9 times 3 gave me the exponent of 27, And then technically there's a 1 here, so I multiplied 1 by 3, and that's how I got 3. So again, I'm going to post a PDF of this, but I did want to go through just verbally some comments here on the homework assignment.